Okay, question 36. You're given a triangle and you're given certain conditions regarding where A, B and C are. A cuts OP in the ratio 1 to 2. So A is the point with P being 3. A must be the point 1, 0, 0. B similarly cuts RP in the ratio 1 to 2. So what are the coordinates of B? 3 along the X, 2 along the Y, and 0 along the Z. Okay. And how about the point C? Well, similar story. How do you get from O to C? 3 along the X, nothing along the Y, and 2 down on the Z. So C is 3, 0, minus 2. Okay, so getting that out of the way and just moving on to the main part of where I did my working. Here we have it here. Part B says, find the area of triangle A to B to C. So I've done a simplified diagram of it. There's A, B and C using the coordinates I got earlier on. We need to get the vector from A to B. Okay, 1 to 3 is 2, nothing to 2 is 2, 0 to 0 is 2. So A to B is 2, 2, 0. How do you get from A to C? 1 to 3 is a jump of 2, 0 to 0 is 0, 0 to minus 2 is back 2. We're incidentally going for this angle here, the angle at A. Okay, I'll explain why later on. Okay, so we've got AB and we've got AC. Now to get the angle at A, we need to get the dot product, AB dot AC. Well, that's 2 times 2 plus 2 times nothing plus nothing times minus 2. So that's going to be 4, 0, 0, which is just 4. The length of AB, you square root each term and add them. Square root 2 squared, 2 squared, 0 squared, add them all up, you get 8. You want the square root of 8. The size of AC is the square root of 2 squared plus nothing squared plus minus 2 squared, and that's another root 8. Working out the size of A, so the cos of A is AB dot AC, which is 4, over root 8 times root 8. A wee bit of working there. Cos of A is a half, so A ends up being 60 degrees. Now, you might remember a formula. The area is a half AB sine C from National 5, where we're talking about that being one side, that being the other, and that's the angle in between. That's the angle we've just got. So the area of the triangle is a half times root 8 times root 8 times sine 60, which is 3.46 square units. Part C is going to be done here on another bit of paper because it's quite large. Okay. Part C says calculate the percentage increase or decrease, so they're not giving anything away, in the surface area of the crystal compared with the cube. Okay, first thing we're going to do is talk about the cube. Now the cube obviously has got 6 faces, each one's a 3 by 3. Okay, 3 by 3 is 9, 6 9s are 54. So the cube without the slice taken out of it would have an area of 54. Okay, now talking about the cube with the slice taken away from it, we do have 3 sides that we can't see. They're the 3 by 3s at the back, the side and on the base. Okay, 9, 9, 9. So each of these ones that we can't see are total 27 square units. And we also have 3 ones that look like that. Okay, that's a small diagram, but there's a slightly enlarged version there for you. Okay. There we have it there. Cutting it up, that's 2, that's 1, so that's a 3, that's 3. There's 1 and there's 1 and there's your cut there. So I've obviously cut it up into 2 rectangles and a triangle just to add them up. That's a 3 by 1. That one is 2 by 2. 2 2s are 4, but with it being a triangle, half it is 2. That was a 1 by 2. So that's 2, 3, 4, 5, 6, 7. So each of these is 7 square units. And we have 3 of them, so that gives you 21 square units. So the total surface area of the cube with the slice off is the 27. That was our 3 9s that we talked about a wee minute ago. There's the 21 that we only just got there. And that's the area of the triangle that we got for part B. Okay, adding them all up, you get a total area of 51.46, obviously, less than the 54 we got earlier on. How much less? Well, 2.54 square units. What's that as a percentage? Well, it's 2.54 over the original surface area of 54, divide it out, times it by 100, and you get 4.7%.